to find the derivative of a monomial, binomial, or trinomial function. Think of this as a function that has been graphed. Here is the x and y coordinate plane with the appropriate arrows and labeling. That should be a y up here and an x. And let's say we graph a function, and this function has all kinds of waves in it. And in this function, f of x equals something. We won't even write out what it is. Let's say you plug in a value. You plug in a value and it ends up being right about here. One of the things that a derivative will do for you is to find the best linear approximation of the function at that given output point. So let's say you plugged in for x a positive 2, and it came back to be right here on your graph. When you find a derivative, it'll let you estimate the best possible linear approximation. For example, notice that the graph is curving this way. So the best possible linear approximation for that graph at that point would be this. And that's something that a derivative will help you do. We're doing pre-calculus stuff now, so we won't be as in-depth into it as you will when you get into college, but this will help you out once you get there. Another explanation of a derivative is it's a ratio. It helps to express a ratio of the change in output to the change in input. Let's say we have the function f of x equals 3x squared. And we want to find the derivative of that. The notation for the derivative is this. And to find the derivative, whatever number is out to the left of the function, such as 3, you keep it there. Whatever the exponent is on the variable, you move it down in front of the variable. And then you subtract 1 from that exponent that's at the top. And then simplify to get your final answer. 3 times 2 is 6, and then x to the 2 minus 1 power is simply x. So you're left with 6x being the derivative, the first derivative of 3x squared. In this one we have f of x equals 5x to the 4th, or not 4th, but the 6th power. And to find the derivative, we move the 6 down in front, beside the 5, and subtract 1 from the exponent. So simplify that to get 30x to the 5th power. Find the derivative of f of x equals 10x to the 6th power. To find the derivative of 10x to the 6th power, you move the 6 down in front, subtract 1 from the exponent. That would be 60x to the 5th power. Find the derivative, the first derivative of f of x equals 9x to the 6th power. We need the first derivative of f of x equals 9x to the 6th, and that will be 9 times 6, x to the 6 minus 1 power, and that is 54x to the 5th. Next up, we want to find the second derivative of f of x of 3x to the 4th power. The second derivative. In order to find the second derivative, you must find the first one. The first derivative will be 4 times 3, x to the 4 minus 1 power, which is 12x to the third. And then to find the second derivative, you'll keep your 12 where it's at, move the 3 down, and then it becomes to the 3 minus 1 power, which would be 36x to the second. This.